that's life. Better to have it than not. All right, let's look at 22E question 3. So find the area of the region enclosed by these two curves. Okay, so this is in general. We didn't go into this in details, but hopefully you did research this. So here's our first curve, and here's our second curve. Plus 4. So without knowing exactly what they look like, if I were to draw a sketch, they're two quadratics. So one is just going to dip below the other. So it's going to be like something like that. And we're going to look for this area here. And that's what this question is all about. All right, but we need to find where these 2 points are. So that will give us our bounds where they meet. So it's a simultaneous equation with the y's will be the same value with here and here, and that's hopefully what you've done. So if you let them equal each other, because the y will be at the same value there, you get x squared minus 3x plus 4 is equal to the other one, 2x squared plus 3x plus 4. A rearrangement of this, I think you end up with x squared plus 6x is equal to 0. And correct me if you're wrong, I think the 4's cancel and stuff. And we can find out that the x values, the two x values, are both 0 and negative 6. Negative 6 from this. Okay, so x would be either of those two. What do we do with that then? Well, we're looking for the area between the two, and this, I think I alluded to how to do this the last day, or you may have researched it. So for minus 6 would be the lower bound, upper bound would be 0. Now, this is where the sketch would be important. Which is above which? So how would we figure out which one's above which? No idea?
I put
Malika?
the 2x squared one was above.
Why is it above?
Well, I thought with like a steeper gradient, it would just like cut through one with a low, like a.
Yeah, it would have steeper gradients, so maybe it's the one below, because it would shoot up and down steeper. Yeah, if you weren't sure which one's below and which one's above, you may need to, it won't be, this might be a calculator. If it's a calculator question, just draw the two of them. If it's a non-calculator question, you probably need to suss out a point between minus 6 and 0. And see, so maybe you could test maybe minus 3, because you know it's going to be halfway. And so sub in minus 3 and x into both of them, and whichever has the highest y value will be the one above, won't it? Does that make sense?
Yeah.
Yeah, so do something like that, Malika. Don't just think, it's very hard to judge which one's above and below just by looking at it. And yeah, I think that this one is going to be steeper. I think this one is the one below, the 2, because if you think about it, that doubling here is going to increase it faster and decrease it faster, or not decrease it faster, but it's going to have that effect. It's going to slope up and down faster either side. So I think that's going to be the below one, which means it's the one to subtract. So you should set up with x squared minus 3x plus 4. Oh, I didn't record this, did I? Oh, I did. Take away then the other one, 2x squared plus 3x plus 4. With respect to x. So that's the way you should have set it up. I have done this already. I think you get minus x squared plus minus 6x as your thing to be integrated between 0 and minus 6 dx. Now, as a kind of side here, which you shouldn't have done, but if it's ever a calculator question, do you know how to put this into your calculator?
No.
Okay, so this is if you have a definite integral where you have the bounds here and there's no anything other than x's here, you can use a calculator to just solve this. And maybe I wasn't planning on doing this, but if I can remember how to do this now, I think you go to math and Number 9 is definite integral. Number 9 in math. So I can type in -6 here. I can type in 0, and I'll put in whatever my thing is here. Now, you weren't supposed to do this because this was a non-calculator question, so but we should get the same answer. And it's x squared. -x squared, take away 6x. I do hope this works. Take away 6x, and that's it, isn't it? Yes, and then with respect to x. Now, hopefully, this gives me 36, and it does. So, did you get 36 for that?
Yep.
Yeah. Like, you might have got -36 if you did it over around, did you? Possibly.
Yeah, I got -36, but like since it was an area, I just made it positive.
Yeah, that would be you'd be marked down in the exam if that was the case. If you just made it positive at the end, do try and if you notice that, maybe you might have to go back and adjust. But yeah, okay. So that's how you do it on the calculator. Any of these definite integrals, go down to math. I'll do that again. Math on the calculator. Scroll down or just press number 9, and then you can fill it in. Okay. All right, so that's okay. So 36 is our answer here, units squared. An answer for this, I think you had to do part B, and I do not think it was as straightforward. Final answer, my goodness. Final answer, Rigel, what did you get for part B?
Well, I got 8.1, but I know it's supposed to be 7.
Yeah.
And
Like, what did you get?
I got like 6.8.
Okay, Rigel, continue. Sorry, I cut across you.
Well, what is it? Just a simple, like, I mean, at least you find the points of intersection, and then that -1/2 is I guess the graph that's above. So then you find underneath that, and then you subtract off the 2x1.
Yeah, so it's that one, the -1/2 one, subtracting the 2x one, yeah?
Is that it?
That's it, yeah.
Well, then I just did something else wrong, because that's
What
what
were your upper and lower bounds? Because I think you have to use the
I got 1 plus square root of 41/5 and 1 minus, yeah.
Yeah. So, yeah, they're correct. The bounds are correct. You've set it up. So the area should be, if you use the -b formula, the area, I'll just write the area. 1 plus the square root of 41/5 and 1 minus the square root of 41/5. And it is the -1/2 one, x squared minus 2x. So it'll be above. And I'll put that in brackets and then subtract the 2x squared minus 3x minus 3 one. Now, that's an absolute disaster to do not disaster, it's just really, really easy to make a simple mistake. But if you've got that much, it's a calculation error from there.
Yep.
Okay. Malika, did you get those bounds?
I used decimals. I didn't use surds.
Okay. So you used the calculator, yeah.
Yeah, I did.
Yeah, so if you had the calculator, you would have just used the definite integral thing. If it was a calculator question, you would have done that. Okay, we won't worry too much about that because that's more of a mess, really. If you got this one, that's fine. It's unlikely to make the bounds that hard in a non-calculator question. It doesn't seem like it's worth the time that you would have to spend. All right, so 22E question 4, which was the one that they've drawn for you, I think. So we're looking for the coordinates of A and B. Malika, can you give us the coordinates of A and B there?
Was this question 11A on page 606?
No, this is question, did I not give question 4 and 22E? Page 605? I think you might have skipped that one. Did you go straight to question 11?
Oops, yeah.
All right. Rigel, did you get coordinates?
Yeah, for A, it got 0.5, 2.5, and B, it got 2, 1.
Okay, yeah, so that means your area should be bounded by 0.5 and 2, and subtract the 2, and I think you end up with natural log in your answer, do you?
Yeah. I think I got the final thing wrong again.
Yeah.
I looked at the correct thing from. I was able to get 1.33 whatever it was, and the answer was just 0.33.
Okay, well let's have a little look at the area. So you found the bounds by a similar method to what we did there before. I think you have to, you factorize a quadratic, don't you, to get them? So
Yeah.
the bounds. This is part B. Part A, I think, is given. Well, not minus a half, just a half. 3 minus x from the diagram is above, and minus 5 over 2x plus 1 is below. Okay, and when I want to, I can integrate this straight away, I think, by rule. Yes, I can. Okay, so it's going to be 3x from the first one minus x squared over 2, and using our ax plus b rule. Malika, what's the integrand of this?
Then let me pin the screen of the whole.
Just this bit, 5 over 2x plus 1.
Do you want me to explain every step, or?
No, just what's the straight integral by rule? Just this bit. Can you remember?
No.
Yeah. So this is one of those special cases. It's going to be, if you want to take it aside, it's 5 times 1 over 2x plus 1 if you want. So its integral would be 5 times, now 1/2, because 1 over a of whatever this number is, times ln this thing. It's a special case because it's x to the power 1 here. Ax plus b type, which you may need to work on. Look at that section again if that didn't make sense to you. This is the ax. So 1 over a, because this is ax plus b. All right, and then we can tidy that up, but we'll do that in the next line. 2 and a half. Okay, so 3x minus x squared over 2. Shove all this together, and you get minus 5 over 2 natural log of 2x plus 1. And that's between 2 and a half. Okay, subbing in then 2 first. I'm going to get 6. Take away 2 minus 5 over 2. So I'm subbing in 2 at the moment. And 2 times, so that's going to be just natural log of 5. That's subbed in 2. And then I'm going to subtract subbing in half. So that's going to give me 3 over 2 minus 1/8, isn't it? That's going to be a quarter times 2. Or a quarter times a half. Minus 5 over 2 and a half. It's going to be 2. 2. Okay. Going to subtract those from each other, so we can probably combine this. That's going to be 4. Take away 5 over 2, and then 5 minus 12 over 8 minus, that's 11 over 8. 11 over 8 plus 5 over 2 ln 2. Like terms combine. These two is going to be 21 over 8. I'll subtract because it's going to be 32 over 8. And these two combine then. So minus 5 over 2. And I can say ln 5 minus ln 2 like that. And of course, ln 5 minus ln 2 is going to be 5 over 2, isn't it? So I get 21 over 8 minus 5 over 2 ln 5 over 2. And because it's a non-calculator question, that'll be the answer, units. Can't do any more than that, squared units. Hopefully that made sense. That's, some tricky, the integral wasn't straightforward at the start here. And the use of natural log rules or log rules here just makes, you probably could have left it somewhere near this stage.
Yeah, I screwed up the substitution of 2 and 0.5.
Okay. All right, 22E then. Oh, no, 22E, question 11. We're still on 22E. And that was the sketch the graphs of x cubed minus 5x and 2x squared minus 6 on the same axes. Let's get a new page for this. I will. Question 11. 22E, and that's page 6. So obviously you can't show me your sketches, but one is a cubic equation, and that will go through 0, 0, I think. This is approximately what my sketch looked like. I think it was from, if I use 2 and minus 2, it's just before minus 2. This is the cubic one. Goes through 0, 0. And pops up after positive 2. Something like that is the cubic one. And then the, found the, it's obviously a U-shaped curve is 2x squared minus 6. Goes through minus 6, doesn't it? So it's going to be down here somewhere. Something like, I think it's inside that then, yeah. Yeah, like this. Maybe you didn't get that. Something like that, maybe. So this is the y is equal to 2x squared minus 6, and this one is our cubic equation. Y is equal to x cubed minus 5x. Hopefully you've got something similar to that. So what we're looking for then, find the x coordinate of their intersection points. So that's, once again, I'll do this. Let the y's equal each other, so they'll be the same. So x cubed minus 5x is equal to 2x squared minus 6. Rearranging of this, we get x cubed minus 2x squared minus 5x plus 6 is equal to 0. Finding those intersection points. How do we find those intersection points? How do you solve that cubic?
Sub in something that works. So I put in 1 just to see.
Yeah.
And then that works out. And then you long division, you can get all your things.
Yeah, so I think 1 does work, doesn't it?
Yeah.
So 1 does work, so that means x minus 1 is a factor, so you can divide all that by x minus 1, as Rigel said, if you sub in 1. And I think you end up with x squared minus x minus 6 or something on top. Yeah, I think that's it on top. Once you divide that in, which leaves you with x squared minus x minus 6, that's going to be x 3 2
I think
minus plus, maybe?
yeah.
Yeah, okay, so there's our 3 factors to make that up. Malika, are you okay with that? I skipped that. I went through that quite fast.
Yeah, I used a different method, but I still got the 3, like the same 3 factorized.
Yeah. Awesome. Yeah. So whatever method you use, that's fine. There's a number of ways. I don't know if this is the easiest one. That trial and error is a bit hit and miss sometimes. So x is going to be there intersecting at minus 2, 1, 3. Was that it? Okay. Yeah, that's it. Part C then. Hence find the area enclosed by it, which is an interesting question. So from, this is the minus 2 one, from minus 2 up to 1. And then they obviously cross again, so my sketch is off. They have to cross again here. So this is, that's too sharp. I didn't actually think about this. So this should cross again. Did you get them to cross again up here? Because it doesn't make sense otherwise.
Yeah, it does. It's a little hard to.
Okay. I didn't put 2 and 2 together there. Yeah, so they cross again up here. So there's 2 areas, the one here, and then there's another one up here. So this is from minus 2 up to 1, and then this one's from 1 up to 3. So, and you can see that one is on top here, and then the other one switches to be on top, so you have to switch them around. So let's write that out. So from -2 up to 1, the x cubed one is on top. You see the cubic one is on top here. So that's cool. X cubed minus 5x minus the other one, dx. And then you would add the area of from 1 to 3, and the other one's on top here, so it's going to be the other way around. 2x squared minus 6 minus the x cubed minus 5x dx. Okay. So you can tidy all that up. You'll get a cubic equation for both of them. Oh, I was going to say, did you get the answer to be, I think, 21 point something?
Well, I got what you put right there, but then I did not get 21. I got like 34.
Oh, geez. Malika?
I got 21, like a mixed fraction, 21 and 1/12.
Sounds good. Yep. Well, I really don't want to do this. So x cubed minus 2x squared minus 5x plus 6 dx. So hopefully, Rigel, at some stage you'll just say, you'll stop me and you'll go.
Oh, yeah, I already see it. So I screwed up the 6. I said both of them I put positive.
Oh, okay, yeah. So it should be minus x cubed plus 2x squared plus 5x minus 6.
Oh, no, I just got, I got them reversed. I don't know why.
Okay, well, there you go.
Yeah.
That's problem solved. Do all that out if you want, or now that you have the ability to do it on the calculator, do it on the calculator. Okay, but this was supposed to be a non-calculator question. All right, 22F then, moving using the y-axis, wasn't it? So we did this in more detail. So I did give you question 3, I think. All right, 22F, question 3, page 610. Oh. See the Badai email me. No. Okay, I'll just have to survive without him. 3a. So we have x equal to y squared plus 1. Oh, that's generous, isn't it, really? And it's bounded by y is equal to 1 and y is equal to 2. Oh, this is very straightforward, isn't it? So you just can integrate with respect to y straight away. Didn't even have to rearrange or anything. 2, 1, y squared plus 1 dy. You get y cubed over 3 plus y between 2 and 1. Sub in 2, sub in 1, and you get, well, what'd you get? Anybody?
For the final?
Yeah, what'd you get? Yeah.
10 thirds unit squared.
3 1/3? Yeah. So
Yeah, I got 3 1/3 as well.
Yeah, 3 1/3 when you sub in 2 1. Just don't want to do that. The second one then, I think, is maybe not as easy, but pretty similar in level of difficulty. Malika, did you get an answer for that? The second one? 3b?
Yeah, I got 12 2/3 units squared.
Yes, yeah, that's it. Okay, that makes sense. So now, volumes of revolution. Very exciting. Talk to me about volumes of revolution, Rigel. What happens?
Well, it's pretty much finding the area and then timesing it by the radius. I'm not the radius, sorry, the circumference. So then your formula, you just put pi in front, and then you have your kind of x squared, like pi r squared.
You square the function, do you?
Yeah, it's like you find both areas, I guess. So you put pi into the integral, and then you just go from there, and then whatever your y or x your function is, you just square that before you do anything to it.
Yeah, that's pretty much it. And I'll do the homework answers here, but I think I'll wait for Badai in order to just go through it in a bit more detail. But just for the homework answers, let's look at them. Question 2, I think I gave you. Question 2A on page whatever that is. It's 612. So you have. Did I give 2? Yeah, I did give question 2A. Y, this is our function. Y is equal to x over 2 plus 4. And this thing is going to be revolved fully around the x-axis, so 2 pi revolutions. So you need to get the from, they give you the balance. So it's this on the diagram. I wonder where I got 0 and 6 from. So it's this thing from 0 to 6. That's going to be rotated around the x-axis. So that means this is going to be squared. So hopefully you did this, and I'll explain that in more detail perhaps tomorrow or next lesson we have. That's squared, and the pi is out the front, and 6, 0 like that. So hopefully you did that. Square this out then. It's a bit messy, but we get x squared over 4 plus 4x plus 16 dx. Still all between 6 and 0 and pi. And then we can integrate all that. X cubed then over 3 times 12 plus 4x squared over 2 plus 16x. And now that's between 6 and 0, and you can multiply by pi afterwards. Sub in 6 just and take away nothing. So you end up with, I think, when you sub in 6, 186 and then pi units. Is that okay? Cubed volume?
Yeah, that's what I got.
Yep.
Okay. All right, so I won't go into too much detail on those. I know the answer for B is 146 over 5 pi, or the decimal equivalent of that for B. And for E, it's or C, it's pi over 2. Whatever way you wrote this, I think this is the way they wrote it. The answers at the back. I think that's it. Units squared. I'll give you the answers to that, or cubed. It is the answer to E, or some perhaps even decimal equivalent.
Yeah.
Is that C?
Yeah, C. Yeah. Do you want me to do it?
Well, I don't know if it goes to the same thing, but I got like 1490 pi units squared.
1490 pi. Might be. Doesn't seem beyond the realms. No, clear. E to the power of 8. I don't know what that is. Minus 1. And then divided by 8.
Yeah, I think it's the same.
thing. Same thing, yeah.
Okay.
Yeah. Sweet. All right, 22G2 then. So solids revolved around the y-axis. So that was very similar to what we did in the other lesson we did before the break, where the y-axis, the inverse, I suppose, work around that. This is the last question, isn't it? Yeah. So for this one, question 4A. Oh, yeah. So we have this thing. It's kind of all right. So we have this. This is part of a circle of some sort, and that's x squared plus y squared is equal to 64. And that shaded region is rotated around the y-axis. Is rotated around this way. There, and we're given some. This is -8 and this is -5. Wonderful. All right, so we do need this in terms of x then. So if you think about it, x squared is equal to y squared minus, no, 64 minus y squared. X squared, just a quick rearrangement, 64 minus y squared. Now, if we remember up here in this example, what this is really is y squared, isn't it? It's whatever y was squared. And if it's the y-axis, then it's whatever x is squared. And we've already got x squared here, so I don't need to re-square this. It's already squared. X squared is this. So that's where maybe the tricky part came in this question. Between -8 and -5, we have 64 minus y squared, which is if x already squared. And that's going to be rotated fully around, so pi times, and with respect to y. So we can do that out. 64y then integrate minus y cubed over 3 between -5 and -8 times pi. And if you sub all that in, I'm not going to do it again, but I think you get 63 pi. Right, did you get that?
Yep.
63 pi. All right, and part B, a hemisphere bowl of radius 8 centimeters contains water of depth. Oh, so this is the same thing. Find the volume of water.
Just in centimeters.
It's just in centimeters. Yeah. So what is it, like 198 or something?
Yep.
So just the same thing. Yeah. Okay. Just converting that to centimeters. 63 times 3.14 gives you 198. Okay. So I'll talk about the sense making of all that a little bit in the next lesson. Rather, but I was here for it. For all of you, I'll set you a few more of these types of questions and see how you get on. Not too much though. We're almost finished this chapter. If you're getting those, that's great. That's great. They're quite interesting and challenging, which is good. So I'll set you a couple of these, not too many. They'll be due for homework. We don't have maths tomorrow, do we? Maths Wednesday. Due for homework Wednesday, and then I'll talk about all the revolutions and volumes, and then maybe we'll get on to kinematics on Wednesday, if possible. Okay? Oh, Badai is here.
Hello, sir. Sorry. I don't know why my Wi-Fi has been down for the past 2 hours.
All right. Well, I'll throw this up on YouTube, and you can watch it back. And I'll still continue. Will wait until Wednesday to go through because we only got 10 minutes left.
Okay.
All the
Did
theories.
Did you go through the entire homework?
Most of it, yes.
Okay. I already did all the questions.
Okay, cool. So you can check them off when I put it up on YouTube. All right, I'll let you guys go. Look out for the homework on ManageBack. It'll be up there in about 5 minutes. And yeah, we'll see you Wednesday.
Thank you, sir.
All right, see you.
See ya.
Thank you.